Okay, so the next is a execution context in a JavaScript. So the execution context contains the code that's currently running and everything that used in its execution, that is variables and the function. During the execution context runtime, the specific code gets passed by parser. The variables and the functions are stored in memory, and executable bytecode gets generated and the code gets executed. The next is an execution stack or a call stack. Call stack keeps track of all execution context created during the life cycle of a script. JavaScript is a single threaded language, which means that it is capable of only executing a single task at a time. When other actions and functions and event occur, an execution context is created for each of these events. Due to the single-threaded nature of JavaScript, a stack is created which has execution contexts. We'll see the pictorial diagram for this execution stack and execution context uh, later in the video. So the event loop, JavaScript runtime model is based on an event loop. The event loop is responsible for executing the code, collect events and processing those events, and executing the queued subtasks. Okay, so the heap stores the variables needed in execution. Call stack, as we seen earlier, when the execution context get created, those will add to the stack. These execution context will add to the stacks. Then web browser APIs. Callbacks wait for the web APIs to complete, or async operations to complete, or timers to complete. Then we have callback or event queue, callback queue or event queue. Once the timers and async operation completes, callbacks are get pushed to the callback queue or event queue. So the callback queue are two types: the macro task queue and the micro task queues. So macro task queues contains the set interval callbacks, set timeout callbacks function, and the micro task queues contains the resolve, reject, and finally handler of the promises or callback function of the queue micro task function. So using this queue micro task function, we can push the functions to the micro task queue. And the event loop, so the event loop keeps an eye on the callback queue and the call stack. If the callback queue has callbacks to execute, it will check if the call stack is empty or not. Once the call stack is empty, it will take first callback and adds to the call stack to execute. Then we have macro tasks and micro tasks. Execution of .then, .catch, and finally handler becomes a micro task, or we can push the uh, task to a micro task using this queue micro task function, and will pass the callback function to this function. This callback function will get pushed to the micro task queue. Immediately after every macro task, the JavaScript engine executes all tasks from the micro task queue before start execution of a new macro task. For example, the set timeout have the function 1 as a callback for set timeout. We have the promise.resolve handler uh, as a function 2, and we have then the another promise.resolve handler function 3. So if suppose we have these three statement in one line, JavaScript event loop will take the function 2 and function 3 first and push to the call stack to execute, and once it finish with the micro tasks, it will take the callbacks from the macro task, which is function 1 in our case. It will push to the call stack. So though we have written this function 2 handler and the function 3 handler after the function 1, it will still execute the function 2 and function 3 before the function 1. And we have event delegation. We can listen the events only on those elements which are existed in a page, but there is a problem if the elements get loaded dynamically after the registering event listeners. So we can register event listeners on parent elements and listen events for dynamically loaded children. In this way we can solve the above issue. So, and this is called as a event delegation model. So in this event delegation model, we just add we add event listener on the parent element, suppose the UL element, and we listens the event generated on the children element, that is all li element in the UL. So we can find the source element using the event.target property, and in this way we can find the which element has generated that event. So in other words, we add the event listener on parent instead of the adding event listener on every child. So as we see here, we have written one click handler function will take the event and will console.log the event.target, and we'll get the UL element and will add the event listener click event on the UL element, and will add the click handler as we declared here. So this will get called when we click on UL element as well as the dynamically loaded li elements in the UL. By using this event delegation model, we achieve the um, better event handling in a JavaScript, and also we don't need to write the event listener on every child element. We'll just write the event listener on the parent element and we'll use it for the child element also. Okay, so the next is bubbling and the capturing. Event bubbling and event capturing. Suppose like when we generate an event on any element in a document, that the same event triggers on all parent elements till the HTML element. When event generates from the child to parent, this is called as event bubbling. So suppose we have UL and LI element and will generate the event on LI element, so that click event will goes up to the HTML elements, and this is called event bubbling. And when the event first generates on HTML element and then for the children till the source element, this is called as a event capturing. So suppose we have generated element on the li, but that click event will generate first on the HTML element, then it will go to the body and then UL and then li element. This is called as a capturing. So we can enable the capturing by passing a third argument to add event listener method as a false. So by default bubbling happens in the document, and as we see here we have this add event listener function. When we pass the third argument as a false to this event listener method, this will work as a event capturing. Okay, then we have let versus const versus var. we'll see the difference between them. Where declarations are globally scoped or function scoped, but the let and const are block scoped. Where variables can be redeclared and updated, let can be updated but cannot redeclare in a same scope. The const cannot be updated and cannot be redeclared in the same scope. Then the third is where variables are hoisted at the top of the scope and initializes to undefined, but in case of let and const they are hoisted at the top of the scope but it does not get initialized, and that is why if we try to access let and const variable before a declaration it gives reference error. Okay, then we'll see how to reverse a string in a JavaScript. There are different ways to handle this string reversing. We'll see some of them. The first is arrays reverse method. So this reverse method doesn't have though this reverse method doesn't exist on the string. So we'll split the string, then we use the it will give us an array. We'll use then the reverse method, and after that we'll join the array as a string. So in this way we'll give it a reverse string. Then we have another way, like we can use the decrementing operator. We'll initialize I to the string length -1 and we'll loop through the each character and we'll uh, append to our variable and will return that variable. So in this way we will reverse the string. Then we have recursions. So okay, so using recursion we have declared this reverse string function and we are receiving the string and we are checking if the string is empty, we will return empty, else we will return reverse string function by passing the substring. We are passing 1 as this will uh, pick the string from the second character and first character we will append to that reverse string function. So in this way recursion will solve our problem. As you see here, reverse string. So this, if the string is not empty, it will first pick the ELLO and it will append to the end of the string and we'll call this function, and in this way we will get the H at the end. Then we'll add the E, then we'll add the L, then we'll add the L, and then we'll add the O, and in this way we will reverse the string. Okay, then the promises. We are going to see the promise methods. First is to create the promise. We'll use the constructor function of a promise, that is a new promise, and we'll pass the callback function which will take the resolve and the reject. If the promise is fulfilled, we'll call the resolve handler, else we call the reject handler. Then we listen for the resolve and reject. As we see here, we are calling then function and we are passing the resolve function and the reject function. For this promise variable we are calling then we have finally. We'll use the promise dot finally and we'll pass the handler to execute on finally. So as we see here, we have written the finally handler, then handler, and the catch handler. So instead of passing two functions to the then, we have used this catch. So if promise rejects, it will call the catch. So we have written this finally handler first. Once the promise rejected or resolved, it will call the finally, and then if it's resolved it will call then, and if it's rejects it will call catch. Then we can create a a rejected promise using the promise dot reject static method. As we see here, promise dot reject, and we'll pass the new error object, and then we will handle the rejection using this resolved as reject handler. So as we have called this reject, it will always call this function. Also we have this we can create the resolved promise using the promise dot resolve static method. Sorry, and this actually value, it's not error, when and we are creating the resolve promise and returning the value. So this resolve will always call as we are resolving the promise. Then we have promise.all method. This promise.all method will return a new promise. This returned new promise resolves if all the input promises resolves, else it will rejects immediately if one of the promise rejects. Then we have all settled. This also will return a new promise, and this returned new promise resolves if all the input promises settles. Means the all input promises should reject or the resolved. Then we have promise dot any method. This will also return a new promise, and this returned new promise resolves if any one of the input promises resolves. If not a single promise resolves by promise dot any, this returned promise will reject it. Then we have promise dot trace. This is also returns a new promise, and the returned new promise will resolve or rejects if one of the promise resolves or reject. So first, when the first promise is resolve or reject, this returned promise will also be resolved or get rejected. So we have seen new promise, then we have seen promise dot then, promise dot get, promise dot finally, then we have promise dot reject static method, promise dot resolve static method, then we have promise dot all settled, then promise dot any, and the promise dot trace.